Today we're going to talk about alkenes and alkynes. They are two other groups of organic compounds that are considered to be hydrocarbons. They're called unsaturated hydrocarbons because they contain double and triple bonds, and they don't have as many hydrogens as a saturated or alkane hydrocarbon. So alkenes have double bonds, as it says here, and you can get their formula by simply taking CnH2n. So once you know the number of carbons, you just multiply that by 2, and you can know the number of hydrogens that would be in the structure. Cycloalkanes are a class of cyclic hydrocarbons in which there's a double bond. So you can have a cycloalkane with all single bonds or a cycloalkene with double bonds. Alkynes are a class that has triple bonds in the molecule. We can get their structural formula by taking CnH2n minus 2. So once you know the carbons, you simply multiply that by 2 and then subtract 2 to get the number of hydrogens it would have. When we're naming alkenes and alkynes, the first thing we do, the same way as always, is to number the longest chain, and that chain generally has the double or triple bond in it, and you want the double or triple bond to start on the smallest or lowest numbered carbon. So for instance, in this case, on this first one down here, we would number, if we started numbering from the right, we would end up 1, 2, 3, 4, 5 with the double bond starting on the fifth carbon. By numbering it from the left, 1, 2, 3, we end up with the double bond starting on the third carbon. So that's the direction that we need to number it. So it looks like this is going to be an octane, octene, because it's an alkene, we change that ending to match. And since there are no branches, and the double bond starts on the third carbon, we're simply going to call this 3-octene. That simply tells us where that double bond is going to be. If it has a triple bond, the only thing that's going to change, the process is the same. You can just tell from this one pretty quickly that you need to start numbering from the left so that carbon number 2 starts the triple bond. It is going to be a hex compound, but since this is an alkyne with a triple bond, it's going to be hexyne instead of hexene or hexane. So since the triple bond is on the second carbon, we're going to call this 2-hexyne. So on this one, we always start the numbering on the cycloalkene. We start the numbering on the double bond, and we then want the branch to be closest. So if we start here, we'll end up with a branch being on the third carbon. If we go counterclockwise, it would end up being on a higher numbered carbon. So we're going to number this way. So this is going to be a cyclohexene. And it looks like since there's a bromo compound on both 3 and 4, we're going to name this 3,4-dibromo cyclohexene. 3,4-dibromo cyclohexene. So that's naming alkenes and alkynes. Let's do a couple of more examples, a little more complex ones. In this case, the longest chain looks like it's going to be this direction, and we want to number it in this direction so that our double bond is on the earliest possible carbon. Looks like we have one branch right here, and that branch is a methyl group. Now we'll learn a little bit more about how to name things like this in the next set of notes, but for now we're just doing a basic nomenclature. This is going to be 2-methyl for the methyl group. And then since the double bond starts on the one carbon, it'll be 1-butene since it is a double bond. So 2-methyl, 1-butene. Finally, on the last one, it looks like we've got the first carbon starting here, since that's where the triple bond is. Looks like the longest branch, we could go up here, but I like to stay in a straight line if I can. So there's my numbered carbons. Looks like there's 2 branches, one here and one here. So this is going to be a methyl group, and this is a methyl group. So it looks like we're going to have a dimethyl situation here. So we have 4, 5 dimethyl. Tell where they are and then how many. 4, 5 dimethyl. And this is a 1 hexyne because it's a triple bond. So that's the name for this compound. Now, as far as drawing them, the first thing I always do is to draw out the fact, first of all, this is cyclooctene, so I'm going to have an octagon here. Let me do it a little bit better than that. Y'all know I don't draw octagons that great, but there's cyclooctene, and I'm going to put the double bond here. It does not matter where you put the double bond, as long as it is, that's where you start the compound. So it looks like we have 1,4-diethyl. So here's the 1. I couldn't number it counterclockwise, but I rather not. So there's the 1, 2, 3. Looks like 4 is going to be right here. Both of those are going to have ethyl groups on them. Those are the ones that just have 2 carbons, remember. And there's my 1,4-diethyl cyclooctene. Notice that the 1 and 2 carbon both contain, they go across that double bond. So that's 1, 4 diethyl cyclooctene. Okay, let's look at 3, 4 dimethyl 2-pentene. So I'm going to draw pentene first. I'm going to get the carbons lined out. So there's my 5 carbons. It's 2-pentene, so the double bond's going to start with the second carbon. Then 3, 4 dimethyl, so it looks like we're going to have a methyl group here. Doesn't matter if I put it on top or bottom, but I usually alternate them so that they don't squish together too badly. So 3, 4 dimethyl 2-pentene, and now I just fill in my hydrogens. Now notice this particular carbon has 1, 2, 3 already, so I just want 1 hydrogen here. This carbon, this next carbon, has 4 already, so I don't put any hydrogens on it. This one needs a hydrogen, and this one needs 3. Remember our rule of every carbon needs 4 bonds. You add up the dashes and the hydrogens, and they better equal 4. So, okay, and the last one. It's heptyne, and it's 1 heptyne. So first of all, I'm going to write down my 7 carbons. And it's 1 heptyne. So first of all, what kind of bond would it have in it? Hopefully you said a triple bond. And that triple bond is going to come off of the first carbon and start off that first carbon. And now I simply funnel in all the other pieces. I've got 5 ethyls, so it looks like the 5th carbon is going to be 1, 2, 3, 4. Here's the 5th carbon. I'm going to put an ethyl group here. And I can do that across like this, or I can do it straight down vertically. Doesn't matter. It means the same thing. And I'll just do that on this one. Since I normally do it like that, I'll just show you that this is another way you can do it. So I could do it like this. Then 3,3,4 trimethyl. So it looks like I need a methyl group here on the 3 carbon, another on the 3 carbon, and then one on the 4 carbon. So there's my methyl groups, and now I just have to funnel in any hydrogens that I need. Well, the first one, since it's already got a triple bond, only needs 1 hydrogen. The second carbon is already full. It's got 3 on the left, 1 on the right, so it gets no extra hydrogens. Carbon number 3 is also full. The fourth carbon needs 1, so does the fifth. The next one only has 2, so it's going to need 2 hydrogens, and of course the end one, if there are no other branches, always gets 3. So there's the structure for 5-ethyl 3,3,4 trimethyl 1-heptine.